Hi, hello everyone. This is Dr. Brahmayya, working as an assistant professor, Department of Chemistry, VIGNANA JYOTHI Institute of Engineering and Technology, Bajpalli, Hyderabad. Today I am going to talk about the osmosis and reverse osmosis. So, outline of the lecture. So, what is osmosis and what is reverse osmosis, and what are the applications of the osmosis and reverse osmosis, and what are the conclusions from this lecture. So, what is osmosis? So, look into this slide. Osmosis, when two solutions of the different concentrations are separated by a semi-permeable membrane, which does not permit the flow of the dissolved salts, then the solvent flows from the lower concentration to higher concentration. Let us see what is solvent actually. What is solvent or what is solute? So, we have to know about the solute, solvent and solution. So, a pure water with solute particles like NaCl, sugar molecules, then it is called solution. Solvent plus solute gives rise to solution. So, this is actually what is solution. So, when you come to know the concept, when you come to know the definition of the solution, solvent and solute, then only we can understand the osmosis. So, for example, there is a conical flask which is having a solvent, and then there is a solute which is poured into the conical flask, then it is become a solution. So, before adding the solute into this conical flask, it is a pure solvent, and after adding the solute particles into this solvent, it becomes a solution. So, before adding it is a pure solvent, after adding it is a concentrated solution. So, we will know about the osmosis now. What is that? When two solutions of the different concentrations are separated by a semi-permeable membrane which does not permit the flow of the dissolved salts, then the solvent flows from the lower concentration to higher concentration. Let us see in the next slides. So, here two different concentration solutions are separated by semi-permeable membrane. So, it is a low solute and it is a high solute in the solvent. So, lower solute particles present in the left side and higher solute particles present in the right side is like some thick color or green color. This is a U-tube apparatus. So, after some time, see the levels of the liquids are changed here. So, it is a high concentrated solution, it is a low concentrated solution. The solvent flows from this part to right side concentrated solution. So, it is the actual happening. So, why it is happening? What is this? This is called osmosis. Why it is happening? The number of solvent particles in the left side, are very high, and the number of solvent particles, I am talking about the solvent particles, number of solvent particles in the right side is compared to less. So, it implies that the higher concentration of the water is left side, lower concentration of the water is right side, whereas the solute particles are very high in the right side, in the left side is nothing, solute particles are present. So, the concentrated one is right side and the less concentration of the solute particles is left side. So, always water molecules wants to try to make a equal sharing of the water molecules on the both sides, H2O's n plus 1, and H2O right side is also n plus 1. It implies that by 2. It wants to become n plus 1 by 2. So, 50% is here and 50% is right side. So, it should be like that. So, this is the actual equilibrium state of the water. So but it is not there now because of the concentrated solution is right side. Some particles are there, solute particles are there, so that the concentration of the water is less and the concentration of the solute particles are very high. So there is no ambiguity is here. It is very clear that so water molecules are very high in the left side. Right side is water molecules are compared to less due to the presence of the solute particles. So the number of water molecules they want to become in an equilibrium state, so they want to move towards to the right side to make the equal point of number of water molecules in the both sides of the semi-permeable membrane. So this is the process actually it is happening. So we will very clearly see in the next slides. This happening is called osmosis. So low concentrated side to high concentrated side when the solution is moving, when the solvent is moving, so when the solvent is moving, then it is called osmosis. So we will see here. So solvent, this is the left side to me, and this is the right side. This is the right side. So solute particles are here. So lower solute concentration, higher solute concentration. So the movement of the solvent is always follows solute particles. The movement of the solvent is always follow solute particles. So this is a semi-permeable membrane. So after some time, what happened actually, by slowly the solvent is moving towards to the high concentrated solution. High concentrated solution, I am not talking about the solvent, high concentrated solution. So then this is become like this is the surface, this is the surface. So right side is concentrated solution, always due to the process of the osmosis, always it will be higher. So some osmotic pressure will be developed. Some natural osmotic pressure will be developed here. Now this is a osmosis. This is called osmosis. Why osmosis is happening? Why osmosis is happening? So there is a hypotonic solution, there is a hypertonic solution. Hypertonic solution is implies that number of solute particles are in the right side or some other side, and the number of solute particles are very less when compared to the other concentrated side. So it implies that one side is very pure or less concentrated solution, other side is very high concentrated solution. So it is high concentrated solution is like a hypertonic solution. Left side is hypotonic solution, so it's in lower in solute, higher in solute. So here the water wants to become both sides equal, 50% to 50%. So that's why they want to make an isotonic solution. Isotonic solution is implies that on both sides of the semi-permeable membrane it should be equal. The number of water molecules on both sides should be equal. So this is a isotonic solution. To stabilize this solution, the flow of the water molecules always towards the high concentrated solution, and then finally it will become no net change of the water. It will be stabilized. On both sides it becomes a 50-50% is reached, then it is like a isotonic solution. See here. So when you look into this figure, this is a concentrated solution in the right side. This is a only solvent. So the solvent is always tries to flow towards to the solute particles. So that's why the osmosis is happening. Selectively permeable, this is a semi-permeable membrane. The water is going from left side to right side, low concentration to high concentration. So this is the actual osmosis, how it is happening. So the green colored one is sugar molecules. So sugar molecules should be dissolved so that the water molecules always flows towards to the solute particles. As we discussed already, in terms of the water concentration, high concentration water is left side, low concentration water is right side. There is no ambiguity should be taken by the students. This here is the very best example how the water is flowing towards to the solute particles. Low concentration solution to high concentrated solution, that is very clear. But in terms of the water molecules, you have to talk about that number of water molecules are very high in the low concentrated solution, and number of molecules of the water molecules are very high in the very less in the high concentrated solution, so that the water molecules always flows from the higher to lower, higher potential of the water concentration to lower potential of the water concentration. That is a very simple topic. You have to understand, the student should understand. So examples of the osmosis in our daily life. If you look into a plant in everyday life, the plants are like growing like anything. It's like very tall trees they are growing. How they are growing up? Because of the osmosis. How the osmosis is happening in the soil? In the soil, the roots of the plant, the hair of the hair of the root, the hair of the root is like this. See, the water is absorbing by the hair of the hair of the root. The small portion, very hairy portion of the root taking the water, because the water concentration in the soil is very high, and whereas in the root there are salts and minerals and sugar carbohydrates. So these are the concentration of the root side is the molecules, the substances present in the root is concentrated one when compared to the water molecules are very high in the outside. Okay, there is no doubt at all, but in the root there are some molecules, there are substances like salts, minerals and sugar molecules present in the root. So through this hairy root, the water flows, tries to flow towards to this one, and slowly absorbing by this minerals. The flow will be like upwards due to the osmosis only. And when the water is going up, here is the suctional force will be developed. Because of the suctional force, when it enters, the suctional force helps or enhances the movement of the water towards to the upward. So likewise, the water flow will be like upwards against to the gravity with the suctional force help reinforcement of the suctional force, and then finally it is going to the stems and then leaves. Once the water is reached to the leaves, what will happen? They will be evaporated. Water lost by transpiration. The loss of the water from the leaves are called transpiration. Because of the water is evaporating, so the flow of the water is always upwards to the trees. So this is actually happening, and this is the mechanism how the trees are growing upward. By taking the osmosis process, the water will be always flows towards upward, so the plants will be grow. And one more example is raisins. The dry raisins, when you watch on the watch glass, if you see the dry raisins, when you put in the water, the dry raisins will be like swollen after some time. Why? Because the membrane, the surface of the dry raisins, like a wrinkled dry raisins, will take the water molecules into the inside of the raisin. Why? Because inside of the raisin there is a sugar molecules, very rich sugar molecules, very carbohydrates are there. They always very concentrated one inside. So the concentrated side is always seeking the water as per the osmosis process. So then after some time the raisins will be swollen. You can see here the swollen raisins. These are the daily life examples by the osmosis. If there is no osmosis, there is no plant. So you have to remember, it's maybe a small basic concept, but this basic concept should be understood by the students. If it is not there, there is no plants. Reverse osmosis. What is reverse osmosis? Reverse osmosis, when two solutions of the unequal concentrations are separated by a semi-permeable membrane, flow of solvents takes place from the dilute to concentrated sides due to the osmosis, as we discussed just now. But whereas there is a reverse osmosis. If, however, hydrostatic pressure in excess of osmotic pressure is applied on the concentrated side, the solvent flow is reversed. It implies that, as you discuss, we will see the one picture now. That is, solvent is forced to move from the concentrated side to dilute side across the membrane. This is called principle of the reverse osmosis. So there is a osmotic pressure was developed in the osmosis process. From the low concentration to high concentration, the solvent is moved. That time the layers, the surfaces of the both sides of the solutions are differentiated by, one is high concentration and other one is low concentration. That time osmotic pressure is developed. So here this membrane filtration is also called the superfiltration or hyperfiltration. So by applying, like for example, as in the osmosis, the osmotic pressure is developed here, osmotic pressure is developed here, osmotic pressure is developed here. So then whenever you are applied the external force here, then the water will be, the flow of the solvent will be from this side to this side. This is called reverse osmosis. So it implies that the solute particles won't be moved from this side to this side, but only the pure water will be moved from high concentration to low concentration by the use of the external pressure. So that is called reverse osmosis. You can see here fresh water. So this is a seawater. Another side, when you are applying the external pressure, the solute particles, salts, magnesium or calcium salts or some other salts, always be here only. They won't move from this semi-permeable membrane. Only the water will be moved. That is, soft water will be, that is, pure water will be coming outside, relieving the only solute particles in the concentrated solution. So this is the osmotic pressure here. This is osmotic pressure. Then slowly you applied the external pressure here. Then the pure water level is now increased. That implies that initially osmosis is happening, and then through the semi-permeable membrane, and then applied the external pressure here, and then the water is moving from this side to this side, and the solute particles are left behind, remains left here, and then the level of the water is increased this side. This is the reverse osmosis. This reverse osmosis is always helpful for the treatment of the water. So pressure greater than the osmotic pressure is called an external pressure, which is applied to remove the solute particles from the pure water, hard water. Sorry. So applications of the reverse osmosis. So reverse osmosis process is a distinct advantage of the removing the ionic as well as the non-ionic or colloidal and high molecular weight organic matter. It removes colloidal silica which is not removed by demineralization, and the maintenance of the cost is also on the replacement of the semi-permeable membrane. So the membranes will be easily replaced, and we can put the new ones very easily. There is no struggle to changing the membrane filters in this reverse osmosis process. So if you look into here, the reverse osmosis, how it is happening here, see, the external pressure is applied in the red mark if you see here. So the green balls are showing that only water molecules are coming out. The blue balls, which are salt molecules, still remains in the same side. So it implies that in the reverse osmosis, the brackish water or ocean water, if you are applying the reverse osmosis process, the solute particles will be remains in the same side where you applied the external pressure, and only the water will be came out from that filters. So this is called reverse osmosis. You can see here. So the lifetime of the membrane is quite high, about 2 years, and the membrane can be replaced within a few minutes, thereby providing a nearly uninterrupted water supply. Due to the low capital cost, simplicity, low operating cost, and high reliability, the reverse osmosis is gaining a ground at the present for the converting seawater into the drinking water and for obtaining water for very high boilers. So this is the the reverse osmosis process. The concentrated solution will be the brackish water or seawater will be here. The external pressure is applied here. Then only the pure water will be come outside. Other unimportant impurities won't come this side. So this is the reverse osmosis process. So conclusions. Osmosis is a natural passive process vital for the life, allowing water to move across semi-permeable membrane to maintain the balance in the cells, support plant hydration, and regulate fluid levels in the animals. It demonstrates how living organisms rely on the simple physical principles to survive and thrive. While the reverse osmosis is a human engineered application of the same principle where external pressure is used to force water through the semi-permeable membranes in the opposite direction, effectively removing the impurities and salts. While osmosis sustainable biological systems, reverse osmosis sustains the human needs for the clean water and industrial processes. Together, they highlight the importance of the osmotic principles both in nature and in technology, showing how fundamental natural process can be harnessed to the solve practical problems. So this is how the osmosis and reverse osmosis always helpful to the our daily life or sustainability of the life for the human beings and the animals. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.